This video is a third type of sample problem for fuel. So we're going to discuss standard enthalpy of formation or delta H F of Hess law. Now the standard heat of formation of reaction, this is equal to the summation of the quantity number of moles times the heat of fusion of the products minus the summation of the number of moles times the heat of fusion of reactants. What is the standard enthalpy change for the reaction 3 moles of nitrogen gas plus 1 mole of water forming 2 moles of nitric acid plus nitrogen monoxide? So we are going to determine the heat of reaction or delta H. Now we have the data for the following. So this is already given. So the heat of fusion or heat of formation of nitric acid is negative 207.4 kilojoules. So this is exothermic. So the heat of nitrogen monoxide is 90.2 kilojoules. The heat of water is 285.8 kilojoules for this reaction. And the heat of the nitrogen dioxide is at 33.2 kilojoules. The following lists are the heat of fusion or heat of formations. So this is already given for this problem. Now let's proceed with our solution. To proceed with our solution, we're going to use this formula Hess law. Okay? The delta H reaction or the heat of reaction or the change of heat of reaction is equal to the summation of the number of moles, and here is the coefficient of the product multiplied with the heat of formation of the products minus the summation of the products of the following of the number of moles for the reactant multiplied with the heat of formations for the reactants. Now let's proceed with the delta H reaction or the enthalpy of formation for this problem. So this gives us 2 moles of nitric acid. So where did we get 2 moles? From the balance equation. Multiply it with its corresponding heat of formation or heat of fusion, which is negative 207.4 kilojoules per mole of nitric acid. So both moles cancels out plus 1 mole. Okay, since we see here a mole of nitrogen monoxide, multiply it with the standard heat of formation for nitrogen monoxide at 90.2 kilojoules per mole of NO. So this is the summation for the products. And then you're going to subtract the summation for the reactants minus 3 moles of nitrogen dioxide, 3, 3, multiply it with the heat of formation for the nitrogen dioxide, 33.2 kilojoules per mole. Okay, so this is minus the quantity. So plus 1 mole of water. As you can see here, the balance coefficient of water is 1 multiplied with the amount of heat of formation for water, which is 285.8 kilojoules per mole. So further simplifying, the whole quantity gives us this one. So 2 times negative 207.4 kilojoules plus 1 times 90.2 kilojoules minus the whole quantity of 3 or distributing the minus sign. So this becomes minus the latter one. But for the first one is 3 multiplied with 33.2 kilojoules minus 1 times 1 or, or negative 285.8 kilojoules. So this gives us our final answer for the heat of reaction or standard enthalpy of formation reaction for this problem at negative 138.4 kilojoules. Now that ends my presentation for fuel combustion or basic calculation for fuel combustion.